With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with a question which says a rod AB of length 1 meter and mass 2 kg is pinned to a vertical shaft and a massless string is tied with the shaft at the lower end of the rod. Length of the string is given as 4 by 5 meter as shown in the figure. If the shaft starts rotating with constant angular velocity omega, that is 5 radian per second, then we need to find the tension in the string. Alright, so we have been given with the situation, so let's try to analyze this. As we can see, when the shaft starts rotating, so due to centrifugal force, this rod AB will tend to move in the upward direction, or we can say basically a torque will be acting on this shaft. So about this fixed pinned point, alright, or hinged point we can say. So due to which a string will be tightened. So the situation will something look like this. So we can say over here clearly, as the rod starts moving upward, alright, a torque has been acted on the rod, and due to this a string get tightened up and a tension T is developed in the string as we have shown it over here. Alright, so we can see first we will try to calculate the torque that has been acting on the rod. Alright, and then we can be able to calculate the tension. So for it, as we can see, the rod is being given to be of continuous mass, so we can consider a section over here of mass dm and length dl. Alright, at a distance, let's suppose small l from here, so we can say it over here, this distance will be small l. Alright, and we can say vertically this distance can be taken to be as y, let's suppose. So, and let's suppose this distance to be as x. So first we will, this mass has been given, we have considered it as to be of dm mass. So we can say every section on the rod will experience a centrifugal force because it is revolving or rotating, we can say. So in the frame of rod, we can say a centrifugal force must be acting in the direction as shown in the figure, that is towards rightward, and its value is mr omega square. So here we can write m dm, r is radius, that is x, dmx omega square. Alright, so this is what the centrifugal force will be acting on the rod. Alright, so we can say this is the force, and we can say this is the direction, that is distance, that is y, from point O we are taking. So we can say torque about point A, or we can say balancing torque about point A will be given by the formula dm x omega square into y. Torque is nothing but it is force into the perpendicular distance. So perpendicular distance from this hinged is y, and the force is dm x square x omega square. So from here we can see, let's suppose this is our equation number 1. Alright, from figure we can analyze, from figure we can say the value of tan theta if we calculate. So tan theta comes out to be opposite upon adjacent, that is 4 by 5 divided by 3 by 5. So this comes out to be 4 by 3. Also we can say from here, if we carefully analyze this small triangle, so from here we can say also tan theta is x by y, or we can say from here the value of x can be written as, or the value of y from here we can write it as to be x upon tan theta. Alright, so if we substitute this value in equation 1, so we can write, therefore from 1 we can say the value of torque. So this torque is d torque, d tau, because we have taken it for the fraction. Alright, so for fraction we can take a differential form, that is d tau, and it will be equals to dm x can be into x into omega square into y can be written as x by tan theta. Alright, so from here we can say this can be written as dm x square omega square by tan theta. Alright, so from here Also we can, if we resolve it further, so we can write the value of dm can be written as lambda into dl, where lambda is nothing but it is the linear density, or we can say mass per unit length. So from here we can say lambda dl x square omega square by tan theta, and here we can give the reason lambda is nothing but it can be written as mass per unit length. Alright, so from here we can see, if we resolve it further, so we can say d tau will be equals to x square omega square dl divided by tan theta into dl can be written as dx upon sin theta. Why? Because if we carefully analyze the given diagram above, so we can write from this diagram the value of sin theta will be nothing but it can be written as x upon this length small l. Alright, in this small triangle we can say sin theta will be x by small l, so we can say sin theta is x by l. So from here we can say uh, L will be x by sin theta, and in differential form we can say dx by sin theta, and here a term of lambda will come. Alright, so now what we can do over here is we can integrate both sides. So we can say now on integration we will get tau over here, and from here we can say the constant values, that is omega square lambda divided by tan theta into sin theta can be taken out, and integration of x square dx will be x cube by 3, and the limit will be from, if we carefully analyze, the rod started from here this position from 0, and it finally reaches to the point where the string gets tightened, that is to the length of 4 by 5 meters. So we can say limit will be from 0 to 4 by 5. Alright, so from here we can say now omega has been given as 5 radian per second, so it will become 25 into lambda is mass per unit length, that is 2 by 1, and divide by mass has been given as 2 kg, length is 1 meter, tan theta is we have calculated 4 by 3 into sin theta. We can say from the sin theta from figure we can say it is nothing but it is opposite upon hypotenuse, that is 4 by 5 only. So this is 4 by 5 into x cube can be written as 64 by 3 into, so here it is cube of 5 is 125. So after solving this value we can say the value of torque comes out to be 8 Newton meter. Alright, so this is what the value of torque we have calculated. So finally what we can do over here is we can balance the torque and we can get the value of tension. So therefore we can write balancing the torque about hinge. We can say if we carefully analyze, the rod is tending to move in the upward direction. Alright, and we can say if we carefully analyze its weight is been acting in the downward direction mg, and we can say also if we carefully analyze it at the end at point B a tension is been acting. So if we wish to calculate this perpendicular distance to get the value of torque, let's suppose this distance to be as x dash. So we know the angle theta is been given as 53 degree. From tan theta we have calculated, so this angle is 53 degrees. So this distance, that is perpendicular distance, will be nothing but it can be calculated as, if we carefully analyze, this distance will be nothing but it can be written as L by 2. Alright, so weight will be acting at a half the rod, that is this distance will be L by 2, and in this triangle now we can say this length will be sin theta will be opposite upon hypotenuse. So sin 53 is 4 by 5 and into L by 2 it can comes out to be 2 by 5. Alright, so if we now write the torque equations over here, so we can say mg into perpendicular distance is 2 by 5, in the clockwise direction we can take it as to be positive, and also we can say tension and the perpendicular distance is 3 by 5, so t into 3 by 5 again in the clockwise direction, so we will simply add them up, and the total torque that has been balancing is of 8 Newton meter. Alright, as we can see it is moving in this direction, and the weight and tension is try to rotate the rod in the clockwise direction. So we can say from this, if we substitute the value, we can say g can be taken as 10, m is given as 2, so 20 into 2 by 5 plus of 3t by 5, and that is equals to 8. So this value comes out to be 8. 8 minus 8 will be 0. Therefore the value of tension comes out to be 0 Newton. Alright, so from this we can say option D is the right answer to this question. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.